Welcome to Homework Lib.
This is a method of initial rates question. What we need to do is look at a couple experiments where we see the change in concentration of only one reactant. If we look at experiments 2 and 3, where the concentration of C2O42- is staying constant, we see a doubling in the concentration of HgCl2, so we can determine the order of the reaction with respect to HgCl2. A doubling in the concentration going from experiment 3 to experiment 2 results in a doubling of the rate. If what happens to the concentration happens to the rate, it is first order, so it's first order in HgCl2. Next, if we look at experiments 1 and 2, we see the HgCl2 concentration staying constant, and we see a tripling of the C2O42- concentration. A tripling of the concentration of C2O42- results in a 9 times increase in the rate. We could figure this out by simply dividing the two rates. 2.9 times 10 to the negative 4 divided by 3.2 times 10 to the negative 5. Because a tripling results in a 9-fold increase in the rate, a tripling squared gives us 9, therefore the 2 refers to the order, so we must have to square the increase in the concentration to get the increase in the rate. Therefore it is second order with respect to C2O42-. So the rate law is simply rate is equal to K multiplied by the concentration of C2O42- multiplied by the concentration of HgCl2. The next part of the question wants us to determine the value of the rate constant with proper units. To determine the value of the rate constant from this equation that we just derived, if we know the rate and the two concentrations, we can solve for K. So we can use the data from any experiment, 1, 2, 3, or 4. We could do it for all 4 of them, calculate K value, and then get an average, or we could just do it for 1. It doesn't request an average, so we'll just do it for 1. I will use the data in experiment 1. The rate in experiment 1 is 3.2 times 10 to the negative 5. We'll set that equal to K multiplied by the oxalate concentration squared, 0.15, multiplied by the concentration of HgCl2, mercury 2 chloride. Rearrangement of this equation is K will be equal to the 3.2 times 10 to the negative 5 divided by 0.15 squared and 0.164. K then is equal to 8.6 times 10 to the negative 3. But what are the units? This is a third order overall reaction. Because it's third order overall, then the concentration units in the denominator need to be 1 less. That's the pattern. So the exponent for the unit of concentration will be 2. So the units for the K value will be 1 over m squared multiplied by seconds. If it were first or second order, the units would be 1 over ms. If it were first order, it would just be 1 over s and so forth. Say it's like fifth order, then it would be 1 over m to the 4th multiplied by time. In this case, it's s. Now for the last part of the question, it wants to know what the reaction rate will be, assuming everything stays constant except for a change in the concentrations of the reactants. If everything stays constant, namely the temperature, then the rate constant will also be constant, and we can calculate the rate using the rate constant we just determined and the concentrations that are provided. The concentration for oxalate is 0.25, so we'll square that, and then the concentration provided for the mercury 2 chloride, HgCl2, is 0.1. So in the equation we determined up here, with the rate constant we just determined here, we can solve for rate. Rate will be equal to 5.42 times 10 to the negative 5th molar per second, when the concentration of oxalate is 0.25 molar and the concentration of mercury 2 chloride is 0.1 molar.